So this is the next part. 2B. The students are asked to determine an experimental value for the acceleration due to gravity, small g, using their data. So the first part here is what additional quantities do the students need to measure in order to calculate g experimentally from the a value. What is a? A is the acceleration of this cart down the inclined plane that we found out using the graph in the previous part, right? So the acceleration here, I know theoretically, this acceleration A has to be equal to g sine theta. If theta be this angle, the angle of the inclined plane, if theta be that angle, A has to be g sine theta theoretically if there is no friction, aerations, and these things. So if we ignore aeration, friction, and other things, A has to be g sine theta, right? So this gives an expression. The additional quantities do the students need to measure in order to calculate this is the sine theta value. So this inclination of this inclined plane, this wedge here, has to be known in order to find out the acceleration due to gravity of the earth. That is, we know 9.8 meters per second square, right? Write an expression for the value of this in terms of A. So from here only, you can see the acceleration due to gravity I can write is A upon G. I can write as A upon sine theta. Okay, where this theta is the angle of the inclined plane here, right? This is the expression. This answer the second part. Now coming to the part C, the students calculate the value of g experimental value that they are getting by the use of this A that we got in the previous case using the graph is significantly lower than the accepted value 9.8 meter per second square, right? The value that the student is calculating is much lower than what is expected. So what is the physical reason other than friction, aeration that could lead to a significant difference in the experimentally measured value? So obviously, if there is a big error in the measurement of this theta, this angle, the value of g that is going to be calculated is going to significantly differ from its expected value of 9.8. So I'll say the answer is the angle of the inclined plane makes a lot of difference here. So the angle of the inclined plane, okay, that is theta here. Measurement of theta, the accuracy in that is going to determine what is the value of small g you are going to calculate by using that A value, right? Now, second part says, briefly explain how the physical reason you identified in part C1, this part, would lead to the decrease in the experimentally determined value of this, right? G, I am getting as A upon sine theta. The value the student is calculating is significantly lower. That means how much he should have got, he is getting lesser than that. The A value is the same. So sine theta value, right? If sine theta value is lesser, the value of G calculated is more. If sine theta value is higher, the value of this G calculated is going to be lower. That means one error that the student could be making is he's measuring the angle more than the angle is actually. So the sine theta value that he should have got is higher than what it should be. Okay, that will decrease the calculated value of small g here, right? The reason is sine theta value. He is finding it out to be more than it should be. There is some error in measurement of this angle. Yes. So this explains the question B and C part of question number 2, right? Okay, thank you.